Welcome to Physics with Vinay. I am Vinay and I'm back for season 2. This is episode number 5 from the Rare series, and today I'm going to be talking about a concept that is often not clearly understood by students. So let's say I have an XY plane and I have electric field lines in the form of circular loops. These are my electric field lines, and the magnitude of electric field at a distance r from the origin is, let's say, proportional to r. So A is some positive constant and the direction of electric field is given by the electric field lines as I have shown. Now let's say a dipole, an electric dipole, a small point dipole is placed at, let's say r comma 0, and let's say the dipole moment is pi cap. So I want to find the force on the dipole. Alright, so I'm going to show you the force calculation by two methods, but they give two different answers, and at the end of the video I want you to figure out which method is correct and why. So let's take a look. I'll go to the next page. So method 1, let me just write electric field in terms of I cap j cap. So I know my electric field is in this circular anti-clockwise direction manner, which was what I was given. So at a distance r, electric field is in this direction and the magnitude is AR. So let's say this angle is theta and this will also be theta. Now you should be able to see I can write my electric field as minus AR sine theta I cap plus AR cos theta j cap. So what is r sine theta? That is nothing but the y coordinate, and r cos theta is nothing but the x coordinate. So let me just write it down. Let me take A as common. So this will be minus yi cap plus x j cap. Alright, and my dipole moment was pi cap. So at a general point I've written my electric field and my dipole moment is pi cap. So now what I will do is I'll write down the potential energy as minus p dot e, which is for the dipole in electric field. So this will become simply pay. So this will be my potential energy when I take the dot product. So now I can calculate the force. The x component of the force on dipole would be minus del u by del x, simply be 0. There's no x term in the potential energy. And what will be the y term? So minus del u by del y. So that will be minus PA. So therefore the force on my dipole will be minus PA j cap. Alright, so this is method 1, calculating the force on the dipole. Now let's go to the next page where I will show you another method, and let's take a look at that. So in the other method is that if I have a dipole, if I break it down into two charges, minus q and let's say plus q, and let's say the electric field at minus q is E vector and electric field at plus q is E plus delta E. So the net force would be minus QE plus q times E plus delta E, and therefore this will become Q delta E. Now if this is delta L, the distance from minus q to plus q, so I can just multiply and divide by delta L. And what is Q delta L? Q times delta L is nothing but the dipole moment. Let me just write that as P times delta E by delta L. Now for a point dipole, delta L is extremely small, infinitesimally small, so that will become dl, and therefore the change in electric field from minus q to plus q will also become dE. So I'll write it as dE vector by dl. So this is my force vector. Remember, dl is the distance from minus q to plus q. Alright, and dE vector is the change in electric field as you go from minus q to plus q. Now let's use this expression. Now I know that my dipole moment is on the x-axis and my electric field lines are in this manner. So dl is basically dx because the dipole moment is along the x-axis and we're going along the x-axis as we go from minus q to plus q. So my force would be p dE vector by dx for this dipole moment. Now on the x-axis, what does my electric field look like? The direction of electric field is very straightforward. It is all along the y-axis, the electric field lines. So, and the magnitude is simply AR, which is R here will become X. So, can I say electric field would be AX J cap? This is only along the x-axis. So, therefore, my force vector becomes P times the derivative of electric field with respect to X. So, that will simply be PA J cap. So we've gotten the force using this second method. Let me just write that down here, method 2. And what's the difference between this method and the previous method? What's the final answer difference? You should be able to see that there's a negative sign in the first method, which means a dipole experiencing a force in the negative y direction, but in the second method, it's experiencing a force in the positive y direction. Alright, so which method is the correct method? I want you to figure it out and tell me in the comment section. Figure out which method is the correct method and why are these two methods giving different answers. Post your thoughts in the comment section and I'll take a look. That's it for today. See you at the top. Good night.